And then the final 30 minutes will not be recorded and will be open for discussion. Good afternoon, everyone. Welcome to the May 2026 session of the Coastal States Organization Member Discussion Webinar Series. Our focus today is on the No Adverse Impact Framework for Floodplain Management in the Coastal Zone, and the ways that coastal programs and their other partner agencies at the state and territory level can advance sound policy and support effective local practice to minimize flood risk. We will have about 60 minutes of discussion that will be recorded. And then following that, there will be a member discussion that will not be recorded and which will provide an opportunity to share your own experience and challenges and provide feedback. We're pleased to have the opportunity with the session this month to highlight the excellent work of our Digital Coast Fellow, Allie Pouliot, as well as examples of what can be accomplished by guest speakers from two member states, Cheryl Clark with Florida and Jim Giglierano with Wisconsin. Allie will introduce our guest panelists more fully after her presentation, but I'm glad to have the opportunity to introduce her and her presentation. Allie is on a joint fellowship with the Association of State Floodplain Managers and the Coastal States Organization. Going on 2 years, she's been developing a project to update the Coastal No Adverse Impact Framework and support materials to help coastal communities in particular and their partners in states work more effectively and deal more realistically and more practically with the uniquely coastal issues that face a lot of our communities. We are so grateful and impressed with the work she's done both on that project and as a joint member of both teams. She's been an absolute star, has really sort of pushed the envelope of what can get done in the very finite amount of time that's provided in this fellowship. And she's also shortly now moving on to bigger and better things. I'm pleased that she'll be continuing to work in the floodplain management space in a coastal state. And so we'll be able to continue to partner with her as an ally in the continued work. So I'm pleased to hand it off to Allie.
Thank you so much, John, for that very kind introduction. I mean, John did a great job introducing no adverse impact, so most of this will be review at this point, but I will present nonetheless on the work I've been doing. All right. The marine economy contributes $369 billion to the gross domestic product of the United States each year. One second. Oh boy. I'm so sorry. Give me one. Changes in the climate are putting coastal jobs and amenities at risk. NOAA predicts that the sea level will rise between 10 and 12 inches by 2050. As a result, up to $106 billion worth of coastal property will likely be below sea level if we don't change course. When beaches and properties near the shore are threatened by more intense storms and sea level rise, how can we protect the tourism that is vital to our coastal communities? Hi, everyone. As John said, I'm Allie Pouliot. I'm a Digital Coast Fellow, finishing up my 2-year fellowship with the Association of State Floodplain Managers and the Coastal States Organization, working on creating guidance and training to empower professionals in the coastal flood risk field to reduce their flood risk. And I'm also a certified floodplain manager. A little bit about the Association of State Floodplain Managers. It is a national nonprofit with a goal of reducing flood losses across the nation. We have members and chapters all across the United States, and there are 4 primary branches. There is the policy team, the certification team, which administers the Certified Floodplain Manager program, the training team, and the research and technical assistance team, which is the team I've been working with in creating the Coastal No Adverse Impact Guidance. Today, I want to show you how utilizing standards above the National Flood Insurance Program minimum requirements can protect coastal communities and their economies from increased flood risk due to climate change. There will be three parts in my presentation, and then we will move on to our wonderful, wonderful other speakers. I'll talk about the National Flood Insurance Program a little bit, and then the concept of no adverse impact, and finally, the process to update the coastal no adverse impact guidance and create training. So, the National Flood Insurance Program provides federally backed flood insurance to properties and participating communities, which is really important because most homeowners insurance policies do not cover flood losses and they can be incredibly expensive. A community that chooses to be in the NFIP must implement minimum floodplain management standards in flood-prone areas. These include using flood-resistant materials and elevating structures above the base flood elevation. And there are more than 22,000 communities in the United States that are part of the NFIP. FEMA creates these flood insurance rate maps that delineate special flood hazard areas, which are the areas subject to that base flood event, or a flood that has a 1% chance of occurring in any given year. In addition, these often show the depth of that base flood event, or that 1% annual chance flood. The problem lies in the fact that the flood insurance rate maps are based on historical hydrologic and hydraulic studies rather than current conditions, and definitely not future conditions. Estimates predict that as much as 75% of FEMA flood maps are out of date, with many not having been updated since the 1970s. If the maps don't accurately represent current flood risk, how can the minimum standards and the mapped flood risk areas account for the increased risk due to climate change and additional development? Where they fall short, utilizing standards above the National Flood Insurance Program minimum requirements can protect coastal communities and their economies from increased flood risk due to climate change. In essence, these higher standards provide a factor of safety as we deal with the uncertainty of a changing climate. And none of this is to blame FEMA. They are short on capacity, and it takes a lot of time and effort to review and renew hydraulics and hydrologic studies. It's just a statement of fact that a lot of the maps are at this point out of date. Higher standards that we could promote include requiring freeboard or additional elevation for structures above the predicted flood height, preserving coastal wetlands, which protect against storm surge and provide vital habitat, mapping shoreline change and erosion risk, and potentially creating setbacks from the shore for structures to be built, and identifying areas that may be subject to flooding as sea level rises, such as identifying areas that are underwater during extreme high tides. The updated Coastal No Adverse Impact Guidance will provide best practices and resources for coastal communities to build resilience to flooding hazards through the use of higher standards. This wonderful partnership between ASFPM and the Coastal States Organization, with help from the NOAA Office for Coastal Management, has been funded through WOLPERT in support of the Digital Coast Connects and Digital Coast Partnership projects. So what is no adverse impact? Can I ask if anyone who's heard of no adverse impact can just raise their hand or give me an emoji or something? Great. I'm going to make this a little bit more complicated. If you've heard of no adverse impact, and it's not because you've heard one of my presentations before, raise your hand. More than I expected. Exciting. So no adverse impact is an approach to floodplain stewardship that ensures that the action of any community or property owner, public or private, does not adversely impact the property and rights of others. It's an incredible philosophy, but this definition is very technical and legal. And so another way to think about it is no adverse impact promotes a good neighbor policy for floodplain management. In essence, if you are trying to stop flooding on your property, you shouldn't build a wall that pushes it onto your neighbor's property. Won't you be a good neighbor? There are numerous benefits to implementing no adverse impact policies, including protecting people, property, and when possible, the environment, now and into the future, empowering communities to go above and beyond state and federal minimum standards, supporting safer, more equitable communities by promoting effective, practical measures to avoid and minimize adverse impacts. And there are also financial benefits. For instance, a 2019 report by the National Institutes of Building Sciences stated that designs based on the 2018 International Residential and International Building Codes instead of NFIP minimum requirements result in a national benefit of $11 for every $1 invested. Additionally, many of the activities above the basic level also qualify for community rating system points, which can result in flood insurance discounts for participating communities, and we make sure to highlight those in the guidance. The no adverse impact philosophy is based around 7 building blocks or pillars of floodplain stewardship that together make a comprehensive floodplain management program. These are, in no particular order, mitigation, public education and outreach, emergency services, hazard identification and mapping, planning, regulations and development standards, and infrastructure. In addition, we have structured this around 3 levels of recommendations in an effort to acknowledge the fact that every community comes at this from a different place. There are state rule and Dillon rule states, which affects how much influence the state program may have rather than the local community. There are regulatory ceilings and various different, and just interest in capacity and time. And so these levels are basic, which is the minimum requirements and the standard practice. This is what you're already doing. Then there's better, which are more effective ways to manage flood risks, and these often qualify for CRS points. And then finally, there's no adverse impact, which are the most effective ways to promote safety, protect everyone's property, and prevent increased flood issues. But again, I just want to emphasize that we know every coastal program, every state is run differently. Some have permitting authorities, some can advocate, others can't. And so this is not a judgment in any way. We are promoting sound policy and trying to help you find a path to better floodplain stewardship, no matter where you start and where you end. So over the years, ASFPM has developed numerous no adverse impact resources. I believe the concept was coined in the late 1990s or very early 2000s. The first toolkit was released in 2003. The first coastal handbook was released in 2007. In the late 2010s, a series of how-to guides were created, one for each of the building blocks. The No Adverse Impact Legal Guide, which provides advice on the legal side of no adverse impact policies, was released in 2023. And I'm working on the updated Coastal Guidance and Training, which will be released later this year. And that is updating that Coastal NAI handbook that is almost 20 years old now. If you would like to look at some of the current guidance, we don't have any of the new information up yet, but I will send that to you once it's out. If you want to look at what's currently out there, I have the link on the slide, and I believe it was also in the message about today's call. So let's get to the most interesting part of this, which is how are we updating the Coastal No Adverse Impact Guidance? There are 5 primary objectives for this project, and our audience is local officials who work on coastal and flood risk issues. We didn't want to say just coastal managers or just floodplain managers, because really this is an effort to break down silos and work together to comprehensively manage flood risk. And also because in so many communities, the people who work on flood risk may be called the emergency manager or the planner. You all wear so many different hats. We didn't want to make someone feel excluded because of their title. We wanted to be inclusive of everyone who works in this space and cares about these issues. So the objectives are primarily to update the recommendations and guidance. As I mentioned, the original Coastal Handbook was written almost 20 years ago, and we want to include the latest innovations in coastal science and technology, I mean, back in 2007, we didn't talk about climate change. In addition, we wanted to create training modules for coastal NAI building blocks to increase the accessibility and really share the word a little more broadly and get the information out there. And then we will consolidate all of the resources onto a new website, increase awareness and use through marketing, and integrate this training material into both ASFPM's learning software as well as the Digital Coast platform. And the final product will likely be released around the end of this year. And we will absolutely share that with you once it is done. Things that we want to update include stormwater flooding. With increasing impervious surfaces, we're seeing more of this kind of flooding. Great Lakes coastal hazards, community-driven coastal relocation, nature-based solutions, vulnerable communities and how to support them, and new building codes like ASCE 2424, as well as I mentioned, climate change. The guidance will have two main subsections. The first is the background, which will include an introduction to the concept of no adverse impact, as well as an overview of coastal hazards in the US by region to let you know what you might want to look for in your area. And then building blocks, which I will not read again, but all 7 will be in there. And what I'm really excited about with this update is that we're taking it from a guidebook to a modular ecosystem. The 2007 handbook, for all the wonderful things it had, was also a 100-page PDF with very few photos, and so it's a little rough to read. Now we are going to be creating individual pages for each strategy on a website that link to related topics. There will be an introduction to each strategy, steps for implementation, eligibility for community rating system points as applicable, special considerations like do you need additional expertise? Are there legal barriers? Resources, including tools, guidance, and case studies. And they'll be tagged with level, geography, hazard, and building block. And I'll talk a little bit more about the tags in just a moment. But what I love is that it allows us to do something like this, where if we start with a recommendation in hazard identification about mapping areas where sea level rise will lead to frequent flooding by 2050, we can link that to a recommendation in planning about restricting development in areas that are going to be flooded frequently by 2050. And then maybe link it to another recommendation in mitigation about acquiring and restoring to natural use areas that will be frequently flooded by 2050 to prevent inundation from spreading further inward. We chose this format for 4 primary reasons. The definitions and links to additional information allow practitioners from various fields and with a variety of levels of background experience to engage. The tagging system allows you to choose the options that are most relevant for your community. So if you're only looking for things related to hazard identification, or things at the better level, or things related to tsunamis, you can filter based on those tags. These strategies are action-oriented, which allows them to bridge guidance and practice, and they have that information to earn CRS credits for that tangible potential financial benefit for your community. And the resources help you accomplish the strategies. So I've been focusing primarily on the hazard identification and mapping block. That is what we are going to focus the rest of this session on. And I've been leading the way, creating a template and a protocol for developing the new guidance. So I wanted to give you an idea of what basic, better, and NAI might look like in terms of one of these building blocks, in this case, hazard identification and mapping. At the basic level, we're just talking about the NFIP mapping requirements. Use FEMA's flood maps and participate in FEMA's updates when they come to update. At the better level, we're talking about mapping risk beyond the special flood hazard area, whether that's looking at additional inundation scenarios, like the 0.2% annual chance flood, whether that's looking at stormwater flooding or repetitive loss areas, or even looking at valuable natural resources that prevent flooding and how to preserve those so that we don't increase our flood problems that way. And finally, at the no adverse impact level, we're talking about mapping complex and or future risk. So looking at future build-out conditions, climate change, compound flooding, and bringing all of that information to create one map about where development should be located and where development really should be avoided. And NAI is not about stopping development at all. It's just about placing it in smart ways where we're not going to put everyone at risk. So I'm almost done, but I do want to tell you a little bit about the training that we're creating. It's going to be the same audience, those local officials who work on coastal and flood risk issues. There will be 9 virtual asynchronous training modules. Each will be about an hour long, and they'll correspond to those 9 chapters that I showed you in the guidance structure. We are hoping to create an in-person version at some point based on time and capacity in the future. It will be hosted on ASFPM's Learning Management System and created through Articulate Rise, and it will be free. In addition, it will offer professional credits through both ASFPM's training program as well as the AICP credit system. So thinking again about that hazard ID section, the training layout may look something like an introduction section on what do we mean by hazard identification and how does it relate to the rest of the building blocks. What does the NFIP require? What is that basic mapping level? And then how do we look at risk beyond the special flood hazard area? What would be better mapping? This might include case studies about high water marks or stormwater. And then we'll look at NAI mapping, future conditions, and complex flooding. This could look at case studies about future development and build out, marsh migration, and compound flooding. Then there'll be a section on bringing it all together, which will include both placing your community on the NAI spectrum for hazard identification, so where are you right now and where do you want to be, as well as highlighting some tools and resources to help implement these activities, like NOAA's Sea Level Rise Viewer. And then finally, a knowledge check. I hope I've showed you that the updated Coastal No Adverse Impact Guidance will provide best practices and resources for coastal communities to build resilience to flooding hazards through the use of higher standards. We are always looking for new case studies, so if you know of communities that are utilizing standards above the NFIP minimum requirements, please let us know. Feel free to email me or to share in the discussion later. And I will be more than happy to take questions later, but we are running a little later on time than I would like to be right now. So I will definitely share these. This presentation will be shared. And if you do have questions, you can also reach out to Eleanor, who's on this call, because as John said, I am moving on to a new position soon. And finally, a huge thank you to Micros Rhode Island, where I found a lot of the photos in the slideshow. They're fantastic. So I'm going to stop sharing and introduce our first speaker. Cheryl Clark is a Senior Management Analyst 2 with the Florida Department of Environmental Protection's Office of Resilience and Coastal Protection. She joined the department in 2008 and has led the CCAR program since its beginning in 2016. Cheryl serves as the Quality Assurance Officer for ORCP and co-chairs the Data Monitoring Team for the Gulf of America Alliance. Cheryl has managed key initiatives, including the Historical Oyster Body Size and Florida Coastal Water Quality Assessment and Integration projects. Cheryl holds a Bachelor of Science in Biodiversity and Conservation Biology from Cedar Crest College. She's a certified project management professional and a Florida certified contract manager. We are so incredibly excited to have Cheryl here, and I will pass it to her.
Thank you. Thank you for inviting me to speak today. I want to start by introducing my amazing team. Dr. Stephen Durham and Tyler Hill work with me here at the Florida Department of Environmental Protection, and Dr. Sean Landry and Claude Kershaw at the University of South Florida Water Institute. And I also want to acknowledge our funding agencies. CCAR is one of the 309 strategies developed by the Florida Department of Environmental Protection's Office of Resilience and Coastal Protection through consultation with the Florida Coastal Management Program's partner agencies. And CCAR is funded primarily by NOAA's Coastal Zone Management Program and Florida Department of Environmental Protection. So Florida has approximately 1,300 miles of shoreline, where you'll encounter numerous ecosystems, and each has a unique mix of plants and animals and other species, and together they contribute to making Florida's marine and estuarine habitats one of the most diverse in the United States. In Florida, about 76% of our residents live in coastal communities, and Florida is the #1 state in the nation for ocean economy employment. Beyond just the material importance, there's also the personal and emotional connection to these coastal habitats. I'm sure that many of you can conjure up fond memories from your time spent exploring these amazing habitats in Florida. Maybe it was catching redfish along the mangrove shores, or scalloping in the lush seagrass meadows that we have, or even diving along the coral reefs. And these are the experiences that last a lifetime and make Florida special. There are 5 important marine and estuarine habitats that we focus on. The first is submerged aquatic vegetation, and it's comprised of seagrass and attached algae, and is found all along Florida's coast. Florida has 2 of the largest contiguous seagrass meadows in the United States, including the Florida Keys and Florida's Big Bend regions. And the water column includes not only the fish and the organisms in the water, but also information about water chemistry, water clarity, and nutrient levels. Coral reefs are primarily found along the southern Atlantic coast, stretching across 5 counties, and Florida's barrier reef is the 3rd largest in the world. Coastal wetlands are comprised of mangroves and salt marsh habitats and are found all along Florida's coasts, and Florida's mangrove forests account for about 98% of all mangrove coverage in the United States. Then oyster reefs are found statewide, although they're most abundant along the Gulf Coast and the northern portions of the Atlantic coast. And oyster reefs are often long-term features of the seascape, existing for many decades or even thousands of years. Due to the size of Florida and the expanse of these diverse habitats, their preservation and management is accomplished through a large group of individual organizations, including local, state, federal, NGO, and academic institutions. And if we can bring together leadership across these organizations and disciplines to work in collaboration, sharing knowledge, leveraging resources, we can coordinate efforts, saving time and money, and improving data sharing at a multi-habitat level. And if we can achieve this level of connectivity, then we can provide the best available science for informing management and policy here in Florida, and help ensure that future generations can continue to make their own special memories of these habitats. But this was not happening because historically differences between organizational missions and limited resources have led to disparate data sets focused on single habitats, hindering collaboration at the scale necessary to create a statewide centralized infrastructure for habitat management information, leading to data that was inaccessible and being underutilized or not utilized at all. And this is a problem because without collaboration and connectivity, individual research monitoring, restoration, management efforts can rarely match the scale of many of the challenges Florida is facing, such as changes to weather patterns, including changes to the frequency and intensity of storms, which can cause widespread impacts to habitats such as coral reefs and submerged aquatic vegetation. Unplanned environmental events such as oil or chemical spills and vessel groundings can cause acute local effects and or broader chronic effects in coastal habitats and ecosystems. And changes in coastal water quality are extremely complex, involving point source and non-point source impacts across entire watersheds. What these challenges all have in common is that they rarely apply to just a single estuary, bay, county, municipality, or study location. And similarly, the habitat distributions often extend across wide geographic areas. So building a centralized data infrastructure and facilitating coordination among research and monitoring programs is the only practical way of gaining insight on these challenges at scale. The importance of connectivity in responding to challenges was highlighted during the 2010 Deepwater Horizon oil spill, which demanded rapid assessment of data and habitats along Florida's Gulf Coast. And the lack of a centralized information management infrastructure made gathering and sharing relevant information on an urgent, short timeline very difficult. Using lessons learned, the Florida Coastal Management Program developed a strategy that would promote connectivity and a concrete way to help address these challenges, focusing on interoperability, so not just having all of the data in one place, but having the data standardized in a format that can be quickly and easily utilized together for management and policy. Through an intensive stakeholder-driven collaborative process, including local, state, and federal agencies, academic institutions, and NGOs, CCAR was developed. The goal was to utilize current knowledge and scientific data to assess the status and trends of submerged habitats and provide the best available science to help guide planning, management, restoration, and policy decisions. We knew that this was going to be a huge undertaking when we went in, so we did a lot of legwork prior to the start of the project. We hosted a series of webinars featuring lessons learned from other states and organizations that had undertaken similar projects, and we learned a lot. The two main takeaways were that we're going to have to be adaptable and that we should engage the end users from the very start. So we identified 3 teams to guide the process: the steering team, as well as the data team, which provides scientific knowledge and expertise, and a partner team that provides the management and policy perspective. We had participation from over 80 organizations and 180 individuals during the initial meetings to identify the stakeholder needs and develop the project scope. And it was through this collaborative, stakeholder-driven process that the 5 priority habitats were identified, including submerged aquatic vegetation, water column, coral reefs, oyster reefs, and coastal wetlands, as well as 16 indicators and 65 parameters. Additionally, the team outlined the criteria for creating a statewide centralized database to house all of the data in one place. Relevant data sets were identified, and the geographic scope of CCAR was defined by using existing partnering organization program boundaries, including the Office of Resilience and Coastal Protection's managed areas, coral regions, the Florida Fish and Wildlife Conservation Commission's Coastal Habitat Integrated Mapping and Monitoring Program boundaries, as well as their Oyster Integrated Mapping and Monitoring Program boundaries, and the National Wetlands Inventory polygons classified as estuarine and marine deep water and estuarine and marine wetland boundaries were all used. In collaboration with the University of South Florida Water Institute, the CCAR Data Discovery site was created and now features standardized data sets from over 60 organizations and 157 monitoring programs for Florida's marine and estuarine habitats. The CCAR Data Discovery is available to the public through the Go to Monitoring Programs button on the CCAR homepage and provides user-friendly access to the program information, and there's no login information needed. If you contribute data to CCAR, you can have access to your program page through the Data Discovery interface and the Login to DDI button. And this allows data providers to update their own program pages, as well as drag and drop their data with no reformatting or duplication of effort. And this is one of the many things that set CCAR apart. So as I just noted, the program's raw data files are ingested in their original format and then standardized by the CCAR project team. So data users have access to both the program-specific raw data files as well as the standardized CCAR data files that can be easily combined with other program standardized data files from the same habitat. And this facilitates meta-analyses, which if any of you have tried to combine multiple data sets from different entities, you know how complicated that can be. And although we do ask programs to only submit quality checked data, CCAR does provide a de facto extra layer of QA/QC through the program editor dashboards, as well as through the data ingestion process developed for CCAR programs. And there are multiple feedback loops throughout the process. The CCAR team receives an email every time a program page is edited. The data providers have buttons on all of their pages to report an issue. And on the public facing pages, there's a report an issue with this program. The programs must provide associated documentation, including protocols for their raw data sets. And these files are available for users to download as well. Program contacts are listed for every program, increasing transparency as well as recognition for the data collectors. And detailed metadata files are included with every data download. Summary information about each program and its available data is easily visible on each program page, and the spatial distribution of the data can be viewed on the mapping pages. And all information is publicly accessible in a user-friendly format. And because the data is publicly accessible, having data in the CCAR DDI also helps many of the programs meet funding requirements and aids in public records requests. So you can access and view all of the programs contributing data to CCAR through the program matrix page. We designed the program matrix to include pertinent information from the program pages, allowing you to assess the comparability of the programs. And programs can be searched and filtered to meet your specified criteria. You can also export your search results, and if you choose the Excel option, the program name is hyperlinked back to their CCAR program page. Each program page is standardized and includes summary information, contacts, links to raw and standardized data files, and program extent maps. So the CCAR mapping features allow you to see the spatial extent of monitoring across Florida. And this map shows seagrass monitoring locations. The different sampling methodologies are depicted by different colors, and you can also identify gaps in where and how data is collected, allowing organizations to focus resources where they're needed. And if you want to learn more about any of the programs or locations depicted, you can select a location and a pop-up will provide detailed information and again, link you back to the full program page. The mapping features also allow you to view monitoring locations by program. You can overlay benthic data and water quality data collected by different organizations, and this multi-habitat approach provides a unique opportunity to view data from different habitats and data providers in one location. In this example, the Aquatic Preserve seagrass monitoring locations are in red, and they're displayed with the Swanee River Water Management District water quality data in green. And this feature allows managers to utilize data collected by other organizations to guide adaptive management decisions and improves partnerships through data collaboration. CCAR also provides valuable information and tools for informing management planning. So utilizing the data in CCAR, the subject matter experts developed trend analyses for each habitat. And these CCAR meta-analyses are being used to create reports, dashboards, monitoring, planning tools, and more. And links to products, scripts, raw statistical outputs, and summaries of the data and model results are all available on the Florida CCAR GitHub site. The maps, figures, and tables available through CCAR reports and dashboards provide a comprehensive picture of how data has been combined from multiple programs and sources and contributes to the meta-analyses. And these figures present SAV program information at the managed area level for Biscayne Bay Aquatic Preserve in Miami and provide an example of what is available through CCAR. The spatiotemporal figures help decipher if changes you see in species occurrence or abundance may be due to changes in monitoring programs, protocols, or locations. And when shown together, these figures allow for a much clearer picture of the meta-analytical possibilities enabled through CCAR. We've also developed site selection tools for water quality and oyster monitoring programs. The oyster sample size and site selection tool is designed to help environmental managers, researchers, and scientists determine where and how much oyster monitoring is necessary within a given area. And some additional examples of CCAR data is being used in making a difference include the Big Bend Seagrasses Aquatic Preserve utilize CCAR to align their programs monitoring methods with other programs, increasing data comparability. Moat Marine Laboratory and the University of Florida, along with the department, are utilizing CCAR data to model seagrass habitat suitability in Florida Bay. The model is the first step in developing the site selection process under the 10-year Florida Seagrass Restoration Plan funded through the Seagrass Restoration Technology Development Initiative. Florida's Coral Reef Resilience Program is using CCAR to identify gaps in water quality data along the reef tract and make recommendations to the Coral Reef Coordination Team on how to address them. This aids in the efforts to assess the relationships between Everglades restoration, the reef tract, and the coastal resilience in South Florida. The CCAR standardized data files are also being used by Florida Fish and Wildlife for these efforts in their dashboards. The Office of Environmental Accountability and Transparency uses CCAR to populate the agency's data catalog metadata, which is a requirement under Florida statute. And this has eliminated the duplication of effort for programs contributing to CCAR. And then the Historical Oyster Body Size Project was a project that was funded through the Coastal Zone Management Program. And in collaboration with the Paleontological Research Institute, the CCAR team piloted a project utilizing novel techniques to assess dead buried shells from living oyster reefs around the state. And the shells were processed and radiocarbon dated, and using bomb pulse curve, goodness, sorry. We were able to calculate the age of the shells and fill a temporal data gap in Florida's oyster data. The data is archived along with the samples from this project, and it has contributed to the work of 2 PhD students at Cornell and Syracuse University and a postdoctoral fellow. And then through the Project of Special Merit Award, the CCAR team worked in collaboration with the Centralized Data Management Office. And we created a monitoring program that aligns Florida's aquatic preserve continuous water quality monitoring programs with the National Estuarine Research Reserve SWAMP program, and established standardized protocols, quality assurance documents, and training modules for the 29 continuous water quality monitoring sites around the state. CCAR has also provided information that supports over 25 scholarly publications to date. And so that is just some of what we are doing and what it is being used for. So thank you for inviting us to speak today.
Thank you so very much, Cheryl. That was a wonderful presentation, and I loved learning more about CCAR. Now we will pass it to Jim Giglierano, who retired in 2024 from the Wisconsin Department of Administration Land Information Program. He served as the Geographic Information Officer for 9 years. Before that, he worked as a geologist for the Iowa Geological Survey and a GIS Extension Specialist at Iowa State University. We are thrilled to have you here, Jim. Thank you so much.
Okay, can you, oops, there we go. Back up. Can you see me?
Yes, we can see your slides and you.
Okay. Okay, well, thank you everyone for being here, and especially our Wisconsin Coastal Management folks for inviting me to talk about our One Map project. And very quickly, I'm going to explain what this is and how we're proposing it to be used in the future. The CCAR presentation was amazing, and so was Allie's, because this sort of fits right in, because this the data that I'm going to be talking about is main federal data sets, and they mainly cover the terrestrial side of what those two folks were talking about. So hopefully they'll all sort of fit together. Anyway, we have a what we're calling the One Map project, and this was funded by our coastal management program with NOAA BIL funding for the last, I'd say, 2 or 3 years. And we've been looking at the data, and our local partners at Brown County are working on trying to integrate it into their county GIS. So in my talk here, I'll be talking about these various things, how this originated, what was the big idea, where we're mapping, and the One Map concept has a particular word that we use, this harmonization idea. And then a few things about applications and lessons learned, and maybe sort of getting into where it goes next. So our background here is a lot of you may be familiar with federal mapping programs over the years. We've heard NWI, the National Wetlands Inventory, mentioned. There's the new National Hydrography dataset the USGS is working on diligently. And a lot of you have probably also run into the CCAP, the NOAA CCAP land cover. And so these are the three data sets that we're really aiming for here. And in the past, these were all derived from different sources and different programs and for different agency mandates. And so they sort of reside in these, what we call data silos. And that, it's nice that we have them available, but it also means that there's things that make life complicated for us when we try to use them. So that in the one map concept, we're talking about harmonization of these federal data sets. And this concept was pitched to us by Dr. Andrew Brenner from the NV5 Geospatial organization. They've done most of our LIDAR in our state. And so one day we were talking about, oh, gee, we really like to be able to do something like this. And Andrew piped up and said, well, let's try this idea I have for a one map. And that was back in 22. So these are examples of those three federal data sets, the hydrography, the wetlands, and the land cover. And again, funding provided by NOAA through our coastal management program. And of course, they're very much into supporting habitat restoration, conservation efforts. And so we were working with our local GIS land information office in Brown County, which is the county that includes Green Bay. And they were our guinea pig and very much interested in being a part of the project. And NV5 was chosen to lead the project. They're building the hydrography layer and the land cover. And we shipped off the wetlands part of it to the St. Mary's, Minnesota Geospatial Services. If you don't know, they do most of the national wetlands inventory mapping in the upper Midwest. So they're a good partner. Our project area here is good old Green Bay. And the outline here is the counties involved, Brown County, and a good chunk of the next door neighbor, Outagamie. And what's really cool is the green polygon here showing the Oneida Nation. And we were very fortunate that they were interested in the project. Sometimes tribal interests are not real happy when we're flying LIDAR over their territories. So in this case, the Oneida folks were very supportive, and we're very thankful for that. So they played a big part in completing the area of the project. These three watersheds, these are 3 Huck 10s, and this is the part of the Lower Fox main watershed that flows into Green Bay. Sometimes this is called the world's largest freshwater estuary, and was recently designated as a NER. And so there's a lot going on here that's pretty cool. And of course, it's a good combination of farmland and suburbs and football stadiums and industrial urban areas. Other data sources, we have the NAIP imagery, the National Agricultural Imagery Program, and the counties provided their leaf off imagery. So those were very useful. Main data source was the USGS 3-depth LiDAR program was a big contributor. What's shown here is that because we're basically a county GIS program and not a state program, a lot of these were flown individually, and so there's a little bit of a effort to get the various county data sets to work together, which the company did for us. So again, the USGS National Hydrography Data Set, sometimes called the elevation derived hydrography. That's kind of more the technical side of it rather than the programmatic side of it. So it's using the LiDAR to extract new streamlines from the LiDAR data. Wetlands inventory, you're probably familiar with. This area has been mapped a couple times, and the St. Mary's folks went through with the modern imagery, the current imagery, and updated the boundaries for us. And then the CCAP, the Coastal Change Analysis Program, and here's a little example of it. Most of the CCAP data around is the 30-meter data, and we had the map at 1 meter. And so, as you can see, it shows quite a bit more detail than sort of the normal CCAP data, which came in real handy. Just to throw in some of the extras that things like this happen during various projects. The folks at NV5 were very interested in mapping forest metrics, not necessarily a federal data set yet, but certainly of interest to those folks. And so they were using a LiDAR to separate tree heights and other types of metrics, and using different tools to identify the forest types. Okay, so again, back to this harmonization. In the CCAR, we heard a lot about standardization. We heard a lot about integration, and this is not what we're working on here. The data is not fully integrated. They still are derived as separate federal data silo type layers, and they're following their own standards. So there isn't like a change in the standards between the layers. What does happen is, because you have all of these layers being interpreted at the same time, there's an opportunity to check him and to see if one is missing something, or if things are illogical or logical, and that cleans up things quite a bit. So that's the main thing about the harmonization. The other aspect of that is we included a lot of local knowledge when we put this together. So I don't think that's really a normal process for many of these things. So, we had local wetland mappers, we had local remote sensing people, we had local people in different agencies review the data and make suggestions. So again, this harmonization, the best example is open water. How do you map open water in 3 different data sets and try to get nearly the same thing? So that was, this little diagram kind of shows the challenge of that. And this is the estuary of Duck Creek, which is on Green Bay. And what was tricky was our LiDAR was flown at the height of the lake level in 2020. which means the shoreline was way inside the normal shoreline. So we had to do some adjustments and map with other data sets to get that to get both boundaries, kind of the high point, and then some other lower altitude type things. This is a really simplified flow chart of the harmonization process. Up here is the hydrography part using the LiDAR and some other data sets. Goes into getting the wetlands kind of delineated and updated, and then finally into the land cover. And what this really doesn't show is that there's some feedback loops in here that kind of, when they did find things that didn't make sense, then they either made brief changes or they had to kind of back up and go to one of the earlier steps. And so that was kind of interesting that they experienced all those things. Again, we're talking about a lot of the applications that you all were talking about in the previous applications, because we're working with a county planning commission. Zoning is a big deal. They give permits for shorelands, wetlands, and floodplains on the navigable waters of the unincorporated areas of the county. So they're always looking to see what's on the ground, what's next to the stream banks, and how that influences what they're planning to do with the land. Okay, and environmentally sensitive areas, another county program, more in the line of protecting areas, and again, having good hydro data that's not based on old USGS topo maps, the 24K maps that you remember. Those lines are long gone and not very accurate anymore. So this helps in these cases. Wetlands, of course, mainly reviewed by the Wisconsin DNR, Fish and Wildlife Service, and you can see kind of the evolution of, you can see it on the photograph. It doesn't necessarily end up in the NWI, but in this final clip here, with the 1 meter raster, you get more of the detail in those smaller areas. Okay, lessons learned. We have when you're doing these kind of projects, what we learned was the original watershed boundaries, the hydrologic unit code boundaries done maybe 10, 20, 30 years ago are no longer relevant, are no longer accurate. So they needed to be done earlier in the process, and so that you're not missing things. Then there's that deal where when the LiDAR was captured in 2020, the lake levels were at a high level, and so if we were just using the LiDAR, then we would have missed a lot of the coastal wetlands that were flooded at the time. Things, little tiny things like grassed waterways were mapped pretty well using the CCAP data, and of course they're not represented on the other two. And so finding those is one thing. We also had some interesting misalignment issues with the hydrography because of the Phragmites makes bumps in the LiDAR data. So you pretty much had to run up and down each hydro line to figure those out. The sequencing of the data production, again, in the normal universe, these layers are produced. Who knows? They might be 10 years apart. They might be 5 years apart. Certainly, getting them closer together is useful. It isn't always going to happen that way, but that's something we want to work towards. One of the things that we noticed was the contractor wasn't used to having a county data set of culverts. And so they weren't used to having a really good culvert inventory to work from. And it makes a big difference in doing that, the watershed boundaries correctly. And then again, having some local knowledge is very important, which we found out. Next steps, and these are just kind of my wishes for the future. This process works very nicely. I think we could move next into doing other federal data layers like field boundaries, the common land units, or we could also do something more interesting like using the NAS data, which crop data layer, and trying to incorporate some of that, which is yearly. And then there's, again, trying to align this process into the overall federal, state, local mishmash of GIS programs. And then this final one is kind of gets to that climate change piece. How do we manage this over time, and look for trouble in the future, or so forth. Okay. Thanks for inviting me. We can certainly answer some questions. These are the folks that were involved in the project, and I'll leave it at that.
Thank you so much, Jim. That was amazing. All right, so at this point, we are open. We're going to turn off the recording if we haven't already. And